In this video, we're gonna look at the period of the graph of the trig functions. Recall the period is, we use the notation p, which is the smallest integer, such that the function at x plus p equals the function at x. The example that we're gonna do, we're gonna sketch a graph of the function y equals sine of 2x for x between 0 and 2 pi, and making a table of the values with the multiple of pi over 4 for the x value. X, the second column is y equals sine of 2x, and the last column is the order pair x comma y. The beginning of the x is 0, and then go by the increment of pi over 4. The next is going to be pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. We're gonna calculate the multiple of the x and then use it as the argument of the sine value. So y, I don't have to write y, so it's gonna be sine of 2 times 0, sine of 2 times pi over 4, sine of 2 times pi over 2, sine of 2 times pi over 3 pi over 4, sine of 2 times pi, sine of 2 times 5 pi over 4, sine of 2 times 3 pi over 2, sine of 2 times 7 pi over 4. Next, sine of 2 times 2 pi. And then simplify the product there, the 2 and the angle. So going to be sine at 0 for the first one. The next will be sine at pi over 2. Next will be sine at pi. Then sine at 3 pi over 2. Sine at 2 pi. The next going to be sine at 5 pi over 2, which is the same as sine at pi over 2, because angle theta 5 pi over 2 will give the same function value as angle pi. So we call the pi over 2, the pi over 2 is the coterminal of the 5 pi over 2. And then next is the sine of 3 pi. The next one is sine of 7 pi over 2, and angle 7 pi over 2 in one cycle. So this is the same as 3 pi over 2. So sine of 3 pi over 2. And where does the 3 pi is the same as pi. The next one is sine of 4 pi. Sine of 4 pi is the same as sine of 2 pi. So we get the way to set up for the sine. And then next we're gonna put in the value of the function. So recall the 5 key points of the sine function of sine of an angle theta is 0, 1, 0, -1, 0, where the 0 is for the 0 angle, and then pi over 2, and then pi, 3 pi over 2, and then 3 pi over 2, and then the last one is for 2 pi. After we compute, we see the angle 0 there, so the value is going to be 0. At pi over 2, the value of the sine going to be 1, and then 0, -1, 0. And repeat another cycle similar way. There'll be 1 here, and then 0, and then -1, and then 0. So we get all the value of the y's and then put together in the order pair form. Going to be 0, 0, pi over 4, 1, pi over 2, 0, 3 pi over 4, -1, pi, 0, 5 pi over 4, 1, 3 pi over 2, 0, 7 pi over 4, comma, negative 1. And the last 2 pi, comma, 0 as the order pairs that we're going to use to plot on the graphing area. Next, we're going to do the increment in a graphing area to cover from 0 to 2 pi. Do the increment here. If we cover this up to 2 pi, make it in the equal subinterval. So this is from 0, pi and 2 pi, and midway going to be pi over 2. This one is 3 pi over 2. And then the smaller one can be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 there. Then we're going to locate the order pairs on the graphing area. Make a list. The maximum value of this graph of this function is 1. The minimum is negative 1. So the increment, we can use the top number here as a 1 and the bottom as negative 1. So from at the point 0, function value is 0. At pi over 4, the value is 1. And maybe easier to use the lower one. Sorry. Just use, so the graph will look nicer. So at 0, function value is 0. At pi over 4, function value is 1. Pi over 2, function value is 0. And then negative 1, 0, 1, 0, negative 1, 0. We're going to connect all the points with the smooth curve. It looks like we have 2 cycles. That one cycle is one that complete or come back to the same function value, and then another cycle start again. All right, to wrap up with this one, so we can see the graph that looks like, as you see the red curve, that's the graph that we just sketched, or the graph of y equals sine of 2x, comparing with the graph of y equals sine x, which is the one that I highlighted in yellow. The y equals sine x has the period of 2 pi. But for the y equals sine of 2x, the period is just pi, because if you look at one complete cycle, from one end to the next end, the cycle stop right there. So this length is from the right end, which is pi, minus the left end, which is 0. So therefore, the period of the y equals sine of 2x is just pi. To find the amplitude is the same way. Since the maximum value is 1, minimum value is negative 1. So the amplitude is going to be 1/2 multiplied by the max minus the min. And it turns out to be the value 1. And also the amplitude for this function is 1, or we can say a equals 1, which is positive number. The amplitude is the same as the absolute value of the a. For the range of the graph, the range is the interval from the minimum value, which is negative 1, to maximum value positive 1. So to wrap up with this, the graph has the period of pi. Doubling the argument, that means the function we are working on is y equals sine of 2x. That's what it means by doubling the argument. Has a reverse effect of having a period. So to compute, like for one cycle, you can compute by setting up the inequality. The argument is 2x. So we set the 2x in the middle piece between 0 and 2 pi as a typical period of the sine graph. And then you solve for x by dividing by 2 all the way. Then we get 0 less than or equal to x less than or equal to pi. Therefore, we get the pi as the period for the graph of y equals sine of 2x. And the note on the bottom, to aid in sketching the graph. Oops, wrong one. We're going to divide the length of the period into 4 equal subintervals. And those 4 equal subintervals going to give you the location to replace the 5 key points value. And we call that as the 5 key points.